Histograms. It shows the frequency distribution of a set of continuous data. So let's build a histogram for a random normal distributed data. For that I'm using rnorm function here with a value of 1000 variables. The function that is used to build a histogram is hist, that is hist. So let's execute this command. And you can see the graph is showing a normally distributed data. If you want to build a data for a that is skewed data, that is not normally distributed, it has different values and frequencies. There is an inbuilt data set that is islands. So it is a data set having the area of different islands. It's a vector of 48 length. Let's execute this command. And you can see it is a skewed data. That means one side the variables or the value is high and the other side is very low. Then there is, you can see in the graph, the values of y-axis, this shows the frequency that is from 0 to 10, 20, 30 and 40. If you want these values in the form of density or probability, what you can do is you can add a sub function that is probability equal to true or frequency equal to false. It goes each way the same. So if I execute this, so you can see because it is a very small value, so it is showing the scientific format. Let me give you an example. This was the data of normally distributed data. If I want the density to be shown on the y-axis instead of frequency, I will be taking the same formula, that is the HIST, inside bracket rnorm. Rnorm is for random variable number, taking value of 1000. And next I will be doing probability equals to true. It is giving me an error saying could not find function rnorm. Okay, so I have written the wrong spelling. That is why it is giving an error. So you can see the frequencies have been changed to the density. So it is 0, 0 0.1, 0 0.2, 0 0.3 and 0 0.4. Now let's go ahead. So when we are building a histogram, if you want any help regarding it, just question mark it and you will get help from R regarding all the arguments or the sub functions that you'll be using in that formula. You will have different examples when you go down. There are examples. There are multiple examples regarding histogram. We will be building a histogram with breaks. So the function that we use is hist. Within the brackets, first you give the name of the data set or the column that you want or a variable. It can be a single variable. Then there is breaks. The breaks is the number of bins that will be created for the histogram. So it is a continuous data. What you want, you should understand the difference between bar plot and histogram is bar plots. They are the individual bars that are created for a categorical data. For when you are plotting a continuous data, histogram helps you with that. You can see there is a continuous bars that have been adjoined to each other with a range of data on the x-axis. I am giving breaks here. The data that I am using here is island. If you want to check what is all in this islands data set, so you can see there are different islands along with the size of their area. So I am giving 5 breaks. So there will be only 5 bars, 5 breaks, bins. Then the title of my graph will be islands histogram. X label will be area range and the border will be of red color and it will be filled with gray color. It's executed. So you can see the border of my bins are of red color filled with gray color, and there are so because of the data set that I am having, it is only split it into 4 bars. Let's go ahead. There will be more examples wherein we will be breaking the bins of the data set. So next is I'm using the data set air quality. There are different variables in this data set. If you want to check the data set, it is air quality. So you can see there is ozone, solar wind, temperature, month and day. So I am taking only temperature from this data set and I will be working on that. First, I am creating a histogram for the temperature variable of the air quality. So you can see it is a nicely distributed data. It is a normally distributed data. We are having y-axis as frequencies, showing the number values, and the x-axis is showing the temperature, the value of each of the days. Next, now we will be adding the labels of this graph. So for that, I am taking the title as the function for that is main. The title name will be temperature histogram. Name of x-axis will be temperature, y-axis is temperature frequency, and last equal to 1 will change the direction of frequency values, that is the top down direction. So you can see the change in the graph. There is title added, x-axis name added, and y-axis name added, and the direction of y-axis variables has been changed. Now we are adding color to the bars. So you can see there is no color. To make it attractive, let's add color to it. So I am using function, subfunction is called that is color, and I'm taking two colors here. So for that I am using combine command. First is the sky blue color, second is the chocolate shade. It is the second shade of chocolate. So let's execute, and you can see it is more attractive now. The graph should be attractive so that viewers get interested in your data. Next, what we are doing is we are removing all the details of these graph, that is the annotations, the names of the axis, and the and the headings, and we will be giving our own limits and names to the axes. So for removing, what we are doing, axis equal to false, annotations and all the limits and the names will be removed. For that we are doing false. Label equal to true. So what is label equal to true? There will be numbers on each of the bins here showing how much is the frequency of that bin. Then we are adding y limit. We are changing the limit of y-axis to 0 to 35. It is already the same, so we are keeping it, and we are also keeping the colors of these bins. So you can see only the labels are shown, all the other things has been removed. Now let's specify our own annotations and axes. So first, inside histogram, I'm taking the data set or the variable. Then I'm giving the heading, that is temperature, again same y-axis and x-axis names. Then last equal to 1. Then colors, I'm taking sky blue and chocolate 2. So now the limits are changed. So x limit will be from 55 to 100 and y limit 0 to 40. And what does density do? Density will lower down the color shade to 80%. Let's see the change. So you can see the heading has been added to the graph, x-axis and y-axis limits and the names has been changed, and the density of the color is decreased to 80%, giving the number of breaks and adding numbers to the bars. So now as we are in frequency distribution, you can see the y-axis, we are in frequency and not probability values. So whenever we are on frequency, we can add numbers to our bars. For that, we are first giving the breaks to our data set. So earlier there is no break. It has been divided according to the data set we are having. We are providing it with 20 breaks, names of the axes, color and labels equal to true. So the numbers will be mentioned over the bins. And I'm changing the limit of y-axis to 0 to 25. So you can see there are 20 breaks now, and there are number mentioned on each of the bins. So the temperature is 6 here, 5. Next, what we are doing is we are creating a histogram using density or probability values. For that, we will be removing all the labels, that is the value on the top of the pins, because they are only visible when the frequency is there. It is better to use labels when frequency is used as the y-axis labels, because it is more tidier to see. If you can see what happens if you will not remove the label values. So for that, what we are doing is we are taking hist command, inside the bracket the name of the variable, 20 breaks, frequency equal to false. So frequency equal to false or probability equal to true, both goes the same way. Then I'm giving the name of title, X label, Y label, las equal to 1, color sky blue and chocolate blue. Let's keep labels equal to true. So you can see you can you can check the values on the top of each of the bins, but it will convert into probability values or the density. So it is the 0.02% or 0.16 part. Now let's add a density line to this graph. So density line will help you to understand how the graph is moving, the area that is covered under the line. Let's add a density line. So the formula for that is lines. Within the bracket, the function is density for the to calculate the density of the temperature. Then I'm giving the line width as 4 and color equal to red. So it will be a red line with width of 4, giving the density of the temperature. So let's make a original graph that we created with all the features, having frequency as temperature, giving the labels to the bins. The bins have been break down to 20. There is headed to the graph as temperature histogram, x-axis and y-axis names.